Okay, so right now we are going to do time and distance graphs. So this page all goes together, this guy. So these tables, all of these things go together. And then there's this side over here, okay? So we have these 4 different graphs, and you can kind of see a little bit about them. There's some measurements on the side. So again, time and distance, because that's what these are, time and distance graphs. This one leaves and then rests and then comes back towards home but doesn't quite make it. This one leaves, rests, and then leaves again. This looks a little bit more steep, so maybe they're moving a little bit quicker. This one is going slowly, stops, and then goes really fast. And this one comes from an opposite direction towards like home or something, rests, and then moves at a slower pace all the way home. So it doesn't start at home. So we have these stories that match with one of these. And then the tables that kind of go along with this information as well. So the first story says Susie and Jill slowly drove to Wendover from Susie's house. So it can't be D because they started at home. Okay, the girls stopped at a rest stop for a while and then raced all the way there. So they drove kind of slowly and then raced all the way there after they stopped. So it could be one of these, not quite sure. So we can write B or C, not sure. Okay, then this one. John sprinted to his mailbox, rested, then ran towards home. Well, the only one that goes back home is this one, and that looks pretty good. Sprinted, rested, and then he ran. Okay, because this is a little less steep, so it would be a slower motion. So A definitely works really well with F. G, during rush hour traffic, Frank drove 2 hours to the airport, waited for his plane to arrive, and then flew to his destination. Okay, so he's not going back either. Hold on. So he drove 2 hours and then waited and then flew. So again, it could be one of these. But let's look at the information to figure out exactly what it is. So this person is moving for 1.5 hours. And this person is moving for 2 hours, then stopped, and then went. So C has to go with G. So that means that B needs to go with E. And that means that H will definitely be D. And let's just make sure that it works. Jenna stayed the night at her cousin's house, which means that she's not at home. Jenna invited her cousin back to her house. On the way, they were driven to the movie theaters. So that makes sense. Then they watched a movie. Okay. And then they walked to the house. Yeah, that works really well. So then down here, we're going to just fill out this table to include what we just did. So graph A matches with story F. Graph B matches with story E. Graph C matches with story G. And graph D matches with story H. Oh my goodness. Then we're going to look at our tables. Okay, so the biggest clue here is that D does not start at home. So it needs to start at something other than 0, 0. And the only one that does that is J. J starts at 0:30. And if we actually look on here, we can see 0:30 is this first dot. And then it starts at maybe a quarter of an hour. There, look, it matches perfect. And then rests at 12, which is the distance of 12. And then it ends up being back down to 0. So yeah, D and J match lovely. So we're going to put a D here. Okay, let's look at this one. I. So I goes from 0 to 20, 40, and then there's a flat spot at 60. So all I want to do is I'm going to look at my picture and find a flat spot at 60. No. Oh, there's 60, and there's my flat spot, so I has to match with B. Okay, now K has a flat spot at 10. Okay, so we look up here, and our flat spots, we have a flat spot at 12 and a flat spot at 10. A has to be K. And then L has to be C. And let's just check. See here. So it looks like after 2 hours, we are now 12 miles, which looks good. And then 3 in, oh, it looks perfect. Okay, so then down here, we're going to write the information. So graph A matches with story K, or table K. Graph B matches with table I. Graph C matches with table L, and graph D, this one, matches with table J. And there we have our answers. Okay, last one. This is Eric and Robbie, and they are racing, and you can see their race. Eric is the dashity line, so I'll just write Eric, and Robbie is the solid line. Okay. So, how far do the boys run? Well, the distance is here, so the race, this is the start, and the finish is up here, and they race 1,600, and the units are meters. How long does the race take Eric? Well, this is minutes on the bottom. Eric is the dashity line, so it looks like he finishes here at minute 9. How long does the race take Robbie? Okay, so he's the solid line, and it looks like he's done here, so minute 10. What does Robbie do from minute 4 to minute 8? So from 4 to 8, he is resting. He's old. So he's just taking a little break. What does Eric do at minute 3? So at minute 3 for Eric, he starts going back towards the start because he wants to go catch up with Robbie. So goes back toward the start. Because he's not getting closer to the finish line, he's getting closer to the starting point, the start line. Who wins the race? Well, Eric, he gets there first. Where is Eric moving fastest? So it's pretty steep right here. It's really steep right here. Looks like that is where he's moving fastest. So between minute 8 and minute 9. Between minute 8 and 9. Where is Robbie moving fastest? And his looks the most steep at the end as well. There's like this steep part, which is not as steep as this. So between minute 8 and 10. Okay, what is the speed of Robbie between 8 and 10 minutes? So Robbie between 8 and 10 minutes. So what we're going to do is we're going to figure out our slope. Our rise, each of these boxes going up is worth 200. So 2, 4, 6, 800. And our run, each of these boxes is worth 1, so 2. So Robbie's speed between 8 and 10 minutes is 800, our rise over a run of 2, which is reduced to 400 meters per minute. Sorry. Meters per minute. And then Eric between 0 and 3. So we look back up here. So here's Eric's line between 0 and 3. So this slope. So it has a rise of 1,200 and a run of 3. So it would be 1,200 over 3, which reduces to be 400. So 400 meters per minute. So they're actually moving the same speed at different times. What's Eric's average speed for the whole trip? So for the entire trip, we have to make a giant triangle. So Eric goes from here to the dashity line and then down and over. That's Eric's entire trip. So it has a rise of 1,600 and a run of 9. So we're going to do 1,600 over 9. And that does not reduce to be something pretty. So we can just say that. Or if you really wanted to get a decimal answer, it would be 177.7 meters per minute. And then Robbie's average speed for the whole trip. So Robbie goes from 0 here and then down and across. So Robbie's distance is still the same because that's where the race is, so it's 1,600, but it takes him 10 minutes. So we're going to do 1,600 divided by 10, which is 160 meters per minute. Okay, I hope this helps. If you have any questions, please let your teacher know. Have a great day, guys, and good luck on your test. Bye.